Welcome back to CriCri Aviation. My name's Jim Payne, and in this video we're going to go over the throttle controls that I created for my CriCri. Now, just like the fuel tank video, I've varied greatly from the plans as far as how I created these controls, just because of the turbines that I'm using and the fact that I have to use sliding potentiometers instead of actual levers to actuate the throttles. You'll get about halfway through this video and I switched directions on how I actually finished the throttle controls, because I ended up with an issue in trying to make the throttle controls as short as possible, because the sliding potentiometers, they don't allow you to have a lot of torque or force on them. I wanted to have as low profile knobs as I could create, but the throttle controls that I created required that your hand was in a position similar to this to grab onto the throttle controls. And as you slide them back and forth, your elbow would hit the canopy. So I had to change it so that the throttles were more of a vertical handle that you could slide back and forth, so it kept your elbow down along your side. And again, I didn't notice this until I actually got them mostly complete, got in the airplane and started testing it, and I'm like, well, this isn't going to work at all. But the other thing I decided to do, because I had to switch to more of a handle, which is similar to how the plans have two levers that you would really grab onto from the sides. But what I decided to do then is, if I'm going to switch to a handle that I would just move back and forth, I started thinking, why do I need two handles? And so I ended up switching my throttle controls to just one lever that actuates both of my sliding potentiometers that then controls both engines. And that's probably going to be controversial to other people who are watching this video, saying, gosh, you really should have two individual throttle controls for each engine. But my thought here was that, again, I wouldn't have done this if I had piston engines. I would have never done this, because you could have a situation with a carbureted piston engine where you could have one engine that would operate at part throttle, but if you put it to full throttle, maybe it wants to quit. Maybe you have an engine that just isn't running right, and you can get one at full power and one will go to 3/4, but if you go above that, it starts running rough and you start having issues. Definitely need two throttle controls in that situation. With the piston engines also, you have a lot of vibration that you need to balance between the two engines. So being able to operate one at a slightly different RPM, or being able to adjust one engine RPM to get it to a point where you don't have both engines shaking against each other, and you can kind of level out some of the vibration. You definitely need two throttle controls. So again, the only reason I'm doing this is because I have two engines that are fully electronically controlled, fully controlled by individual potentiometers, and it's running through a full FADEC system. If these engines aren't running right, they're just going to shut off. I couldn't see any situation where I would be running part throttle on one engine and not have the same throttle position on the other. I'm not going to be dealing with vibration issues like on two strokes. So again, my feeling was it simplified the throttle controls, and to me, I couldn't see, again, any reason not to do it. I felt like it was a safer, simpler option than having separate throttle controls. And you'll see in the video I explain and kind of go through this whole thing again and explain a little bit in further detail about why I made that decision. But this is really designed to be a single engine airplane. The only reason it has two engines is because a single engine with a large propeller would be too big, and it was easier to just create an airplane with two smaller engines and two smaller propellers, but it really acts as a single engine airplane. And that's the way I've decided to just treat this, especially with the fact that I'm using these turbines. So what I'm going to do is take the camera, and I'm actually going to get in the cockpit. I'll show you how the throttle controls work so you can see. Again, if you want to watch the rest of the video where I go through the details of how I created the throttle controls, go ahead and watch it. You'll see about halfway through where I switch gears and decide to go a different direction on my actual throttle handle. So again, if you don't not subscribe to the channel, please subscribe. Please like the video, and let me grab the camera and we'll get in the cockpit. So now that we're sitting in the cockpit, you can see the throttle lever that I created to actuate my two sliding potentiometers, which are mounted underneath this this plate right here. You can see I actually used a linear rail and bearing underneath here to support the throttle lever, which will move back and forth like this. It's actually quite strong. And then underneath this plate here, I've got 2 aluminum parts that I machined that encapsulate the tops of the sliding potentiometers that are right here. So they're not bolted to it or anything. They just, go around them and then slide them back and forth. So there's no direct connection between the throttle lever and the potentiometers, which puts, almost zero force on them, which is kind of what I was trying to achieve here. So this actually works really well. You'll see in the video I did have to add some resistance to this to make sure that this would actually stop at its position and have some resistance to it and not just slide back and forth on its own. You'll also notice here, don't laugh at me, but this is a Harbor Freight flashlight that I used as my throttle lever. And I was trying to look for a piece of tubing that I could use in the shop here to create a handle. And when I found these flashlights laying in my toolbox, I was like, there's a nice lightweight aluminum anodized tube there that would work quite well as a throttle handle. And it actually worked out perfect. Cost me $1.50, I think, and it comes with a button on the top for the smoke system, so I can turn the smoke system on and off. So anyway, watch the rest of the video if you want to see the details of how I created this. And again, you'll see in the beginning, first half of the video, how I did something completely different and then changed to this in the end. But I actually really, really like this. It's very comfortable to use as you're sitting in the airplane. Even just resting your hand on here, it's quite comfortable. So again, thank you for watching the video, and please like and subscribe to the channel. So I started making a bunch of parts that go in the cockpit area of the airplane. I bent these according to the plans, and these are the supports for the throttle controls. One of these is supposed to go on the flange on frame 4, and this one here is supposed to go on the flange of frame 3, or in the center of frame 3. And then there's supposed to be a wooden piece that goes across here that actually holds the mechanical handles. Now, I'm not installing mechanical handles in my airplane. I'm actually installing basically a potentiometer for controlling the throttles on the turboprops, but I wanted to kind of use the same setup here. Now, the only issue I have is that my potentiometers, which are just long sliders. Let me go grab those real quick. Let me show you what they look like so you can see what I'm trying to do here. So this is the throttle control that I'm going to use that connects to the Arduino that I programmed to run the turboprops. And so this needs to mount in between these, and what I found out is that the distance from end to end on this potentiometer is exactly the distance from let's say inside of this bend here to inside of this bend. And since this has to be mounted up in here like this, what I'm actually thinking about doing is flipping these brackets around. In other words, take this bracket, put it over here on frame 3, take this bracket, put it over here on frame 4, and then I have plenty of room to fit this in between here. And then this will mount to a plate that comes off the top here that I can just extend out to the end of these brackets on either side, and then I'll just put some kind of cross support underneath here. So looking at it from the side of frame 4, this will look like this, but it'll be covered from top to bottom here with whatever covering I do across the front and across the top, instead of the reverse where you'd see this on the side with the top plate maybe ending here or overlapping. But I think I can use the same brackets and just flip them around. It gives me a little bit more room, and I think that's going to work on my airplane pretty well. So I've got the throttle control mounts installed here on the side of the fuselage. I did have to create these gusset plates that go on the forward cowling for the forward canopy. So I made these out of 32 thousandths. I bent them. You can see I've got this one here on the right side. Also, those are pretty easy to do. I actually took an angle gauge and measured from here across to here and was able to cut those out on the CNC machines because there's no real dimensions on those parts. There's just a picture of it in the plans, and they kind of just tell you to make it to fit. But like I said, I was able to do it on the CNC machine, cut them out, and they fit perfect the first time, which was nice. So I didn't pop rivet these in, but I have these held in with Clecos. And what I'm trying to do is figure out how I'm going to actually make the plate that's going to hold the throttle controls. I'm trying to do something a little bit different than the plans because I've got, you know, the sliding potentiometers, you know, for the turboprops that I have instead of the standard cable and lever linkage assembly. So I cut this out on CNC machine 2. And what I'm going to attempt to do is, actually this goes dropping stuff. And so this gets installed this direction. The potentiometers obviously fit in those slots there. And then these are the holes for the switches that are going for each one of the ignition systems. And what I'm going to attempt to do is, this is going to go in about like here somewhere. And what I'm going to do is bend it so that I actually cover this top part here across, and then we're going to bend this across here. And then I have pre-drilled what should be the marked holes for the screws that we'll put in here, and then we're going to put some floating nut plates in at these two positions here to hold this in. And we're going to see if that works. I can go ahead and screw in the potentiometers and attach the switches. We're going to kind of mock this up and see how the fit is before I actually put anything and install anything permanent here. I'm trying to get all these controls done so I can figure out where I'm going to run wiring. I've got the new throttle circuits completed. I got to figure out how to mount those in here also. Somewhere underneath this is my assumption. But yeah, just trying to get everything fit in here and figure out how I'm going to run wiring behind the panel, how we're going to actually make the instrument panel. And, you know, again, this is all kind of going in conjunction with finishing the fuel tank even, because I need to make sure everything's fitting in here and that I fit in the airplane properly. So let me go ahead and see if I can bend this, and we'll see if we can get this so that it actually fits in here on top of these throttle control mounts. So I did want to point out that I did put joggles in these throttle control mounts that attach here, because this does have to go over the top of this 32 thousandths corner gusset, and then it also has to go over this lip here, 20 thousandths lip for the you know, this fuselage flange here on the side, and then attached to frame 4. So I did that there, and I also did another joggle on this one too, just so you're aware that that's another thing that I had to add to these that, again, they don't show you that in the plans, but I did that figuring it was important to have those fit flush. Well, this is my second attempt at creating a throttle mount panel here. This is the first one I did before that we were looking at. What I ended up having a couple issues with is that when I put the switch here at this spot in the top, the terminals on the back side were actually going to hit frame 3 here. So what I did is I moved this switch forward about 6 millimeters. The other issue I had is the end of the switch here, cover plate, actually was sticking up. There's overhanging the edge of this plate here, so I added another, I think it's 12 millimeters to the end of this and made it a little bit longer. So I moved the switch down, made this a little bit longer. The other thing I did too is I came back here and made the back side of this plate a little bit longer to cover up kind of the overhang here, where the bracket there attaches to the side of the fuselage. It just looks a little bit nicer, I think. It also gave me a little bit more space here to possibly rest my palm of my hand. I'm not exactly sure. You know, the plans show, you know, levers coming up here and you're moving the levers back and forth. Because I'm using potentiometers, I'm going to have you know, very low knobs basically on top of those that'll slide back and forth. So I kind of wanted a little bit more space to rest the palm of my hand if I needed to on there. Again, until I sit in the airplane, I'm not really going to know if that was a good idea or not, or if it should have even been longer. But I think it looks good like this. And since I did make this out of 32 thousandths, I'm really glad that I ended up putting this bend at the top and making it flat across here, because it made this plate much stronger. Had it just been a flat piece of metal, I would have had to use thicker aluminum or reinforced it somehow, because the end here, even with the switches, would have been very, very flimsy. But putting that 45-degree bend in there really stiffened it up. And it kind of seals off the top here once it gets pushed against here and the rivets get installed. I think it'll look pretty good. So since I do have this fit in here, and I think this is going to work, and this panel on top is just going to be screwed down to these brackets, so I think what I'm going to go ahead and do is I'm going to, these corner brackets have to be finished first on the, you know, for this forward cowling. So what I'm going to do is pop rivet these corners into the side of the fuselage, but not into the
the forward cowling frame yet because I still want to take this on and off, but I can attach these permanently, and then if these are attached, then I can pop rivet these throttle support brackets on top of it, and then I can just screw this on and off as needed, you know, if I need to get behind it to get to anything. But I think everything I can get to from underneath here, even the potentiometers themselves, can just unscrew and fall out. And then back underneath here is where I'm going to actually attach the those Arduino throttle controls that I made, so I've got to work on that too. But yeah, and there's good access back here to get to all the wiring behind the switches, so I don't think I'll need to get I don't think I'll need to take anything off except possibly this top plate. So let me go ahead and get those installed, and I ordered another switch, so I'm going to try and get all of the potentiometers and switches installed in this fairly quickly. In fact, I'm trying to figure out exactly where I'm going to mount those throttle controllers that are going to get mounted underneath here, and that's what I'm going to work on next. So I have the two throttle panel brackets installed. I pop riveted them onto frame 3 and frame 4, so they are ready to go. And the next thing I'm going to do is go ahead and attach this with a few screws, and that's what the final project is going to look like. So I'm making an attempt here to make some knobs for these potentiometers that I'm using for the turboprops. So you can see there was no holes in this lever arm here. It's made of steel, which is pretty strong. So what I did is I marked a hole here that I'm going to drill through using this as a template. So what I'm going to do is try and make a knob that's this size, and I'm going to attach it to the potentiometer through this slot that I created on the bottom here. And what this is just two 80 thousandths pieces of aluminum that I cut out on the CNC machine and just pre-drilled them, and then I recessed a spot in the center around the bottom here to be able to put a bolt through, hopefully on either side. And then what I'm going to do is on either side of these plates, once they are attached to the potentiometer, I'm just going to make like a wooden knob that attaches through either side through that center screw hole. So that's what I'm doing right now, just trying to mark these potentiometers and see if I can drill a hole through that steel attach point here, see if I can get a little screw and nut through here to hold these in there so that I can attach the round knob part that I'll just, like I said, create out of a hardwood or something. That's what I'm going to attempt to do here with both potentiometers, to see if I can get some knobs created. So I got one of these mounted on the potentiometer, and it actually worked quite well. The fit's very tight, which is good. And then what I did is I had some hardwood just laying around. I think this is white oak. I went ahead and cut out some approximately 3/8 thick, they're a little bit thinner than that, discs that I'm going to then drill some holes through, and we'll just attach these to either side of the potentiometer here handle, and then I'll clean everything up, smooth everything out, and I think I'll have one of the handles done. I'm basically going to repeat that process for the other potentiometer here, see if I can get a handle on this one. So here's basically what the final throttle control quadrant, I guess you'd call it, looks like. With the knobs installed, potentiometers are installed. I've got the two switches on the front here for the right and left engine ignition. That seems like it's going to work really well. These knobs, I made them just wide enough so that they would still clear each other, so that they can be actuated separately, but that you could almost pinch them together and slide them back and forth without, you know, putting any undue side pressure on the potentiometer. So I think this is going to work quite well. So I moved on to the next step of trying to figure out how to mount underneath here the Arduinos that I'm using for the basically the servo emulators to be able to use these potentiometers to control the ECU for the turboprops. So what I did is it took me a couple different tries, but what I did is I bent this cover plate that I have set up to mount, let's see, underneath here, oops, like this. And you can see it's going to cover, basically it covers the bottom side of the potentiometers, which is nice. There's still a little bit of a lip here that covers the edge of the plate, and then there's going to be one screw on each end which will hold this plate in place, so with two screws I can just drop this thing out. And what I'm planning to do is inside of here, that's where I'm planning to mount the Arduino controllers, which are going to be mounted to the back side of this. Similar to that, there'll be two next to each other, and then I'll be able to do all the wiring connections right inside of there, and then it'll be easy just to drop this panel out to get to them, or to get to any of the wiring that's behind there for the, that's going to connect the throttle potentiometers, the switches, the LEDs that will be in the dash panel to indicate that the ignition is on or not. And then I've got the power connection, which will go to the front where the battery is going to be. And then I've got one connection that needs to go to the front also for the ECU. So I think it's a good place to put all these. They're basically hidden underneath here, out of the way, and easily able to get to these from the cockpit without having to go through any access panels or anything else. So I'm going to keep working on this, see if I can get the actual throttle controllers mounted on here, and then we'll go from there. So I finished installing the throttle controls, and I put this carbon fiber covering on top of it, but this is basically where I stopped. Now, I tried to make a video showing the issues with the throttle controls that we're going to discuss moving forward here, but the video didn't turn out. It turned out it cut off partway through, so I'm just going to kind of talk over this image here. But you can see me sitting in the airplane here, and there ended up being a huge problem with the throttle controls in how they were set up, because if you try and put your hand over the top of those two knobs and move the throttle controls back and forth, with your palm would be down and your fingers would be wrapped around the top of those knobs, your elbow is sticking straight out the side of the airplane. So there's no way to slide them back and forth with your elbow sticking out to the left, because it would hit the canopy. So the only way that I could actuate these throttle controls is if you were to pinch them between, let's say, your middle finger and your thumb and slide them back and forth, but that's not very safe. You don't have a really good grip on it, and it's hard to actuate any of the throttles individually. So I had to stop here and try and figure out a way of fixing this. Now, obviously the plans show longer levers that you could grab, like if you were grabbing your hand on a vertical pole, with your palm facing facing inward to the airplane. You could grab those and actuate those back and forth, and that works quite well. But I can't extend the arms of these knobs up any further than this, because of these sliding potentiometers don't have any real strength to them as far as being able to put leverage side to side, or even front to back. They'll break fairly easily. They're just designed to have a very low sliding knob on them. So I kind of had to start over here with at least the top part of the throttles and the knobs themselves. So what you'll see in the next video, because I jumped right into, after I'd already done a bunch of changes to this, because I didn't know how I was going to fix this. So what you'll see in the next video coming up is that I purchased, first of all, a linear rail. And if you know anything about CNC machines and linear rails, they come with a bearing on top, or usually attached to the rail, depending on what size. And the rails come in all kinds of different sizes, and the bearing blocks that attach them come in different sizes. But with a bearing block sliding on a linear rail, it's very smooth. They're very strong. And so what I did is I bought a linear rail that would fit in between the potentiometers on top of this existing throttle control plate. And then I used the CNC machine to make a mount that would allow me to mount and screw down the linear rail to the mount, and then screw down the mount to the four existing holes that were supporting, or four existing screws that were supporting the potentiometers that are mounted underneath. And by doing that, that allowed me then to attach a throttle handle or knob to the top of the bearing block on the linear rail, and all of the forces from your hand sliding back and forth, bending side to side, would be taken up by the linear rail. And then I just created a encapsulation piece that would attach to the bearing block and actually go over the top of the potentiometer's knob, or potentiometer lever, with the knobs removed, that is sticking up through the throttle plate there. So again, I didn't cover a lot of this because I was kind of just winging it. I didn't really know what I was doing, and I didn't know if what I was doing was even going to work. Now, the other big thing here, though, is you'll notice I went from two knobs to a single control lever. And I had to think long and hard if that was a wise thing to do. But I went through the process thinking, you know what, I don't have a situation where I could have an engine that, let's say, isn't running well, where maybe it's operating at part throttle, but it won't run it at full throttle, and I need to throttle that one back to keep it running. And the other engine, I can run at full power. I don't have the situations with these engines because they're full ECU FADEC controlled engines. If they're not running right, they just shut off. And if they shut off because of a fuel issue, they auto restart. So I don't have any direct control to these engines other than an electronic throttle, potentiometer basically. So I couldn't see a situation where I'd need to try keep one engine running part throttle with another one full throttle. They're either going to be running fine or they're going to shut off and not be running at all. And I felt like that would happen with even a single engine. And again, the single throttle control is just going to control both engines all the time. So it doesn't really matter if the shutoff engine has a throttle that's moving. It doesn't matter even for the restart process. So the only time I need to throttle one engine separate from the other is during a startup process, because when you flick the switches there that are there on the throttle plate, that turns the ignition on, and then the start sequence is that you have to advance the throttle past half and then bring it back to idle, and then it starts the start sequence. Now, that's not a big deal. I can do that with one engine, start one engine, get it running, and then when I go to start the second engine, I just advance the throttle past half real quick and back down to idle. It takes a second or less, and it just will throttle up the existing engine that's already running a little bit when it starts the second engine. So they can both be at idle. I can have them start up separately. It's not a big deal. And with these engines being so close together, there is no really dissimilar thrust between the engines. There may be a slight amount, but it's not enough to worry about. And I thought, I can simplify this whole process by just using one throttle lever to control both engines. And I think it's actually a good solution. Again, I wouldn't do this if I had two-stroke piston engines, but I think it makes sense for mine to simplify it and use one throttle control. Now, the other thing that got a little funny here is that you'll notice in the video, the lever that I used for my throttle control, or for my throttle handle, is actually a Harbor Freight flashlight that costs, I think, $1.50. So what I did is I took the insides out of it and I used the tube as the throttle lever, which actually fits your hand very well. It looks great. And then it does have a button on top that you use to turn on and off the flashlight that I thought I could connect eventually to a smoke tank to be able to turn on and off the smoke system on the airplane. So for $1.50, I got a really nice, anodized throttle lever that is super light. And it looks like it's going to work really well. If you sit in the airplane now with the new throttle controls, which you'll see coming up, it's actually quite comfortable, and you can just wrap your hand around it. The button's right there for your thumb. You can slide it back and forth, and it seems to work great. So I'll start the next part of the video here where it's just going to jump right into me trying to figure out how to get that linear rail so that it has some resistance on it, because it's a bearing block sliding on a steel rail, and it slides with no resistance at all. So because the throttle needs to be able to be put in a certain position and stop, I needed to create something to create resistance on the the linear rail to at least have it so that I could set the throttle in a position and not have it worry about it moving. So we'll get into the next part of the video right now. So I want to make one more enhancement to this throttle control, and that is to add some additional friction to the movement of the handle. Now, there is some friction on here right now. In other words, I can move it back and forth fairly easily, but I'd like to have a little bit more friction on here. And what I'd also like to have is that I'd like to have it where it's at idle, that it takes a little bit more effort to get it off of idle, where it almost has like a snap lock. And so what I'm thinking of doing is just having a metal tab that sticks out from underneath the handle here that rides on top of the rail here, when we'll actually catch the edge of the rail when it's all the way at idle, so that it actually flips over the edge a little bit, so that it takes a little more effort to pop it off. And then I want to actually attach that same tab to the front side of the handle so it does the same thing at full power, where if it's at full power, it takes a little bit more effort to pop it back off of full power on that end also. So that's what I'm going to attempt to do now. So I'm going to take this apart and just try and figure out if I can create some kind of tab that will ride on top of that rail that fits on top of the linear rail bearing underneath the handle there. That's my goal. So let me take this apart and let me see what I can fabricate that will fit underneath there. And I'm going to do some test pieces, I think, with some strips of aluminum just to get the shape correct before I actually cut it out of steel and try and bend the steel part. And I'm going to try and make it out of stainless steel, and I'll show you when I get to that point what I'm going to make it out of, because again, it's a little bit strange use of material, similar to using the flashlight as the handle here. So when we get to that, I'll show you what it looks like. So let me get this taken apart now. Okay, so I took the throttle control apart, and here's what I'm going to attempt to do. These are the blocks that I machined that go on top of here and screw on top of there to attach the bearing block to the actual potentiometer arms that are there. And what I'm going to attempt to do is, let me see if I can get this. Oh, hold on a second. Well, I'm not going to be able to set these up. But anyway, what I'm going to attempt to do is to cut a recess, kind of like a track down the center of these two. That's 8 millimeters wide, that I can recess basically this into it. And then I will bend the ends down around here so that I can go ahead and attach that to the bearing block. Now let me see here. Yeah, that's pretty much the same width, so I was a little concerned that it might be a little bit too wide, but anyway. Now I started off by just cutting this at 2 inches because I was going to see if I could get 3 out of this ruler, and this ruler is actually what I'm going to use to make the spring material that I'm going to install here as kind of my wiper, or my what I'm going to use to actually make additional pressure on here and kind of give some resistance to the throttle control. Now this is just a cheap stainless steel ruler that I got at Ace Hardware. I think this was $3. I'm going to cut this down once I get the shape made out of this and get something that seems to work right. I'll cut this and then I'll bend this. Now I did this at 2 inches hoping that I could get 3 out of the 6-inch ruler, but I can tell right now that this is not going to be long enough likely to bend down around the top of here and have the tabs come down here. So I'm going to probably have to make something a little bit longer. But this is my test aluminum piece. This is 1/2 millimeter or 20 thousandths. This ruler is also exactly 1/2 millimeter or 20 thousandths. So this is the best material that I could find that was kind of small and wasn't very expensive. That was somewhat similar to a spring steel. This is not spring steel at all. It's just stainless steel, but it seems to be tempered. You know, it seems to really resist bending quite a bit. So I think this will work pretty well, and it is stainless steel. So I don't have to worry about having like bare steel in here or anything, or having to paint anything. And obviously using something like spring steel would be better, but I was going to have to order something off of Amazon or figure out how to get some kind of spring steel and then figure out how to cut it. And I just thought, well, this is going to work pretty well for this, and I can at least get 2 out of this if I have to, because I can cut it in half and cut it down to size to fit. So that's what I'm going to use for that little bit of resistance that we're going to add here. So let me go ahead. I'm going to have to cut a longer one of these. I think I'm going to use 3 inches so I can simulate cutting this in half and then having 2 pieces out of it. And I'll start bending it down on the ends so it fits over the top of here. And then I'll probably bend it down maybe at a 45-degree angle, put a little loop on each end. And we'll see if we can get something that fits. And once I get something that fits there, we'll cut this to match it and see if we can finish this up. Well, here's the first attempt at bending something out of aluminum to try and just mock up what I'm trying to do here with this resistance additive to the throttle control here. What I do want to do is actually install this on the throttle control to test it. It gets very tricky down here in the end as far as the angle here and how long it needs to be to make sure that it skips over the edge on the front and the back of the the linear rail, so that I can get that kind of detent at full throttle and idle, and then not have too much pressure on this as this comes back up onto the rail, because this has to slide across the rail and create some friction but not too much. To So what I'm going to do is take these over to the mill and just, with these two together, do an 8mm groove down the center that's about 20 thousandths thick, or maybe a little bit less, so that I can mount this, in between here, and it'll get sandwiched between that and the top plate that goes on top of there that holds these onto the top of the bearing and the stick mounts too. So let me see if I can get that done. I'll see if I can get this reattached, and then I'll slide this back and forth and see how it works. But let me get this groove in here first. Let's test this one, and we'll see what we need to do after that. So here's what this looks like with this adapter that I installed to try and get some additional pressure on the throttle controls, and it works. The only issues I'm having is that I've decided that having any kind of detent on the top and the bottom is not a good idea, because it takes a little bit too much force to pop it loose, and then you don't get a good transition from idle on up just above idle, or from full power just down just below full power, which you want to have work very smoothly, so you can just bump it down off of full power, or even bump it up above idle without having it jump. I don't like the jump feeling on either side, so I'm not going to do that. But because I'm not going to do that, then I don't need this little tab on both sides. I could just have it on one side to provide a little bit of pressure, and depending on how it works with using the stainless steel, I may only want to do it on one side, but I'll do both when I make it out of this. And then I can always cut this one end off and just bend it down flat so that it creates at least a lip along this side of the bearing block, and then have the tab on probably the top side, so that it doesn't show on the bottom side. But that's what I'm thinking about doing. Because this is made out of aluminum right now, it's a little bit sticky. I don't really like the sticky feeling that it has, but I think that's because it's aluminum on steel, which tends to gall a little bit, and it doesn't flow smoothly. So we'll test it with this. If this doesn't work out, I'm just gonna maybe think of a different idea than this to use, but we'll go ahead and test it out, since I did buy the $3 ruler to cut up anyway. So here's what I ended up with those little tabs that create the resistance on the rail, and this actually seems to work really well. I did have to do a little bit of greasing of the bearings and greasing of the linear rail just to make sure things were not sticking at all, but it works really well now. So I tried to mount it in here so I can move it, but I can actually bend these little tabs by just pinching them together, and I can go back to where there's little to no resistance on the linear rail, and then as soon as I let off of them, of course there's a fair amount of resistance on here that allows it to slide back and forth. So it's not going to move on its own at all, and that's kind of what I wanted. It was just enough so that there was tension on this all the time, and again, if I pinch these two together, which lifts them off the rail, I can slide it freely. So I think this is going to work pretty well. So what I'm going to do probably next is just cut those tabs off a little bit shorter. Let's see if I can hold this on here. Make those tabs a little bit shorter so they're not sticking up so high. I do want to mount, obviously, this back on top of here, and I don't want those tabs catching on my hands or my fingers. But the other thing I'm thinking of, just to finish this off, is to cut a circle piece that I can put the carbon fiber fake stuff on the top of, and slip it down at the base of where the handle here is, and it will cover these tabs and cover the square part here, and actually kind of clean this up a little bit so you don't see at least this stuff that's right around the base of the handle there. It'll kind of cover everything up and kind of finish it and make it look nice. But I think that's the only thing I'm going to do to finish it off. I will cut these off a little bit shorter, again, so that whatever cover plate I put over the top of this will be these will be right below that. I want them to stick up a little bit because I like the ability to almost be able to adjust these, because if I get a pair of pliers on here, I can bend them up just a little bit by grabbing onto those tabs, make it a little bit looser. I do have to pull it completely out to bend it down a little bit more to make sure that it provides additional tension if I wanted to, but right now it's just about perfect. It did take me a little bit of practice bending it up and down and getting the fit just right, but it seems to be perfect now. So yeah, let me finish cleaning this up. Let me see if I can get something I can cut a circle that'll fit around the base here. We'll see if we can clean up the rest of this and get it installed back in the airplane. So here's what I came up with for a cover. I went ahead and I had some 2.5-inch circular stock And I went ahead and just cut a piece off and just put this in the lathe, and then created this little cap that will fit on top of here. I did cut grooves in the end to go on top of the rail there, and this basically fits on top of here and covers up the rail. Oops, I do have to put 2 screws in this, so oops, there we go, there we go. So this will slide back and forth, and this actually ends up acting like a hand rest, which works out really well. So I'm going to go ahead and drill a couple holes because I got to make sure this doesn't turn. I'm going to put a countersunk screw here and here on each side so I can make sure that this doesn't turn and get stuck on the edge of the rail when it goes past it on the ends. But anyway, this looks like it will work well. And it's nice because it covers up everything that's underneath here, all of the exposed parts underneath here that are around the bearing block, and also the little drag supports that I created here. But this is working great. I mean, I'm actually very happy with how this turned out. But anyway, let me get the screws installed in here. We'll get this tacked down. I'm going to install it back in the airplane with the flashlight back on there again, and we'll test it out. Well, here are the throttle controls now installed in the airplane and complete, and they are working perfectly. I also did install the cover down there that you can see, and on the other side of that cover underneath the throttle controls is my 2 Arduinos that are connected not only to the 2 switches here at the front, but also to the 2 potentiometers under the throttle controls here, and then those wires continue also on up to the ECUs that are behind the instrument panel. So I do have everything connected now, and everything seems to be working perfectly. So again, that's the end of the throttle control video. Thanks for watching.